The CSAP management platform provides deep integration with Spring Boot. This includes several options for deployment. Spring Boot jar files may be directly deployed to the operating system, leveraging the CSAP Java package. Spring Boot CSAP templates optionally may specify a generic Java container image where the selected jar file will be passed to be started. A fully contained Spring Boot container image may be deployed using either Docker or Podman container implementations. And finally, Spring Boot may also be deployed in Kubernetes. The screencast today will be focusing on Spring Boot deployments when directly deployed on the operating system and leveraging the CSAP Java package. The CSAP Demo Lab includes several Spring Boot services. Today's screencast will use the services provided by the CSAP GitHub, including CSAP Agent, CSAP Admin, and CSAP Verify service. The source repositories are publicly available at GitHub. Feel free to download to learn more about them. To get started, let's open the CSAP Admin service. Then, click on the Edit button to view the service template. CSAP specifications may be edited directly or via the forms. The CSAP Admin service is a predefined template included with the CSAP installation. By default, predefined templates are not editable, but I have gone ahead and switched the source setting for the demo. The OS Process tab includes settings that are common to every CSAP template type. Items such as the OS Process priority and the CSAP service startup order. For Spring Boot, the active profiles, Jvm parameters, and any environment variables may be specified. Environment variables may be specified either as name value pairs or by importing from a CSAP environment configuration map of variables. Here, we can see the single sign-on variables will be loaded. The Packaging tab enables port specification for HTTP along with verification to ensure uniqueness. It also enables optional support for HTTP sticky sessions and load balancing. It leverages the CSAP HTTPT package, which provides Apache ModJK support. CSAP application definitions support multiple target environments, such as dev, test, production, and as many as you wish. Items such as database connection strings, log settings, are often unique per environment. Files and environment variables may be associated with one or more environments to achieve desired configurability. For Spring Boot, jar files are extracted to the service working folder. Any files associated with the runtime environment will be copied into the appropriate subfolder. This will be demonstrated during the demo deployment. The service template job attributes enable any OS operation, including launching Java runtimes, log rotation customization, and file system cleanup. While the CSAP admin service is using the defaults, the CSAP agent includes many examples of each of these sections. The service source attributes enables teams to deploy directly from a Git repository or from a previously built version from Artifactory. It's also possible to upload a jar on demand. The service alerts attributes enable teams to define resource consumption limits. At the specified setting, both the user interface and REST APIs will reflect alerts in progress. At the kill threshold, defaults at 200%, the process will be killed to prevent impacting serviceability on the host. For Spring Boot, an optional specification of the Spring Boot Micrometer REST endpoint is available. This enables real-time viewing of performance data via the CSAP Live view. The service performance attributes enable collection from a REST endpoint of a JSON payload. Simple JSON path expressions are specified to extract the value from the metrics deployment retrieved. While the service live collections are on demand, the specified performance metrics are always collected and integrated into workflows in all of the CSAP portals. While any REST endpoint may be specified for metric collection, using the Spring Boot Micrometer endpoint provides the most flexible options, such as using a single AOP expression to collect data from every Spring interface. Having looked at the service configuration, let's return to the Deployment tab and examine the available views. This time, let's use the CSAP agent Spring Boot service. Selecting a Spring Boot service will show the state of all deployed instances along with the latest resource consumption. Spring Boot service trends may be viewed by selecting one or more instances and selecting the metrics view. Resource consumption trends can be investigated in the context of deployments. This enables early detection of issues during migrations. For Spring Boot with Micrometer enabled, both application and Java trends are available. Resource consumption and performance trends may be further investigated using the Analytics portal. The Analytics portal is typically deployed in a separate CSAP application on separate infrastructure to ensure availability. Views may be customized as needed to investigate performance and resource consumption patterns. The deployment README view links to the associated Git README file. Note, this README file can also be typed inline in the CSAP service definition. The Logs view provides a real-time feed of the various Spring Boot log files. Teams may quickly switch between instances and they also may select different log files to view. Hitting refresh on the logs will restore the default file associated with the instance. Note, by default, CSAP supports auto-parsing of the log files. Here we see the default raw unparsed file. And we can also switch to the Log4j details view. Note, in this view, a couple of additional fields are visible. Items such as the thread, the class, and the message. The Deployment tab also provides quick access to the associated service definition files. The files may be edited and then quickly redeployed. The Jobs view enables execution of any of the jobs associated with the service. For demonstration, I have added a simple ls job. The job may be invoked with the default parameter or customized as needed and executed. Let's go ahead and deploy the CSAP Verify service. To simplify the logs, we'll just go ahead and deploy a single instance on a single host. By default, the first instance is selected. We'll go ahead and select deploy, and we'll use the Maven deployment for this example. The deployment proceeds really quickly, so let me go back through the files and actually show what happened. When we clicked on the deploy button, the log view was automatically activated and the deployment began. Looking through the logs, the key concept is that the jar file was copied from the Maven repository and it was copied to the file system. Once that completes, CSAP automatically triggered the start since the checkbox was selected in the dialog. Looking at the start logs, we can actually view the steps. The key one being there was already another instance running, so it went ahead and killed the existing instance. Then it went ahead and performed jar extraction, and it highlights the directories where it was exported to. Finally, if there were property files for the targeted environment, and the current environment is dev, it actually extracted and copied those files into the class. Finally, it actually triggers the Java execution of the JVM. Now it's key to note, although there's several log files available, as highlighted when I open up the dropdown, if you have previously selected a view, whichever service instance is selected, the default log file that's been defined in the definition is the console.log, which is why it's the default file that's being shown here. Returning to the Verify Service Deployment tab, you'll now note that the first instance that we deployed now has a version of Snapshot, while all the other remaining instances are still showing the 21.11 release. Having recently deployed the service and looking at its log to ensure that it started okay, we can now proceed to launch the new service instance. This is a simple Spring Boot application for verifying infrastructure. Selecting option number 2 and then going down and clicking on Send Messages is a quick way to trigger activity in the log. I've clicked it a few times. Now I can return to the deployment console and we can click on the logs. You can see that we actually have the messages appearing in the logs. Now we can explore the deployed instance a little bit more. Going back to the main deployment view, select the drop-down and select Files. Note that the deployed service that we selected is highlighted in the Selected Services view, and the File Manager view is customized to only show the verification service. We can actually show the full file system or revert back to just our filtered view. Opening up the Deployment tab, we see the top level of the working folder, which is typically under CSAP Platform Working and then the service name. You can see that we have the Java temp directory, the Java log directory, the version folder, as well as the jar extract. If we open the jar extracted folder, we can navigate down into the classes folder. Teams often like to come in here, modify files, and quickly restart without doing a full jar extraction. A convenience mechanism for that is simply the designated property folder, which is simply a shortcut down to those files. Depending on your components, you may have some files that you can edit without even requiring a restart. One of those, for example, is the log4j file. I'm going to quickly edit and add a debug statement. So to do that, I'll just copy an existing item and then customize it. Here, we'll turn the entire Spring framework into debug mode. I'll go ahead and hit Control S, or I could have clicked on the button. Depending on how you've set up your components, this may be immediate or near immediate. I've currently got my log4j polling every few seconds. So to trigger the use case, I'll simply go back to my Verify service and I'll send a few more messages. And then I'll go back to my log view. And now note we're now seeing debug statements in the output. While the CSAP application portal enables us to quickly transition between different instances that have been deployed across multiple hosts, we can get access to the log view also through the agent dashboard. Just verify the service you want has been selected and then click on logs. And you can see once again, we have several debug logs in the output. The agent portal also gives us access to several other key views that will help us understand the context for the running environment. For example, the resource consumption patterns such as the disk, the sockets, are all viewable through the console. The default view shows the last 4 hours, but we can quickly modify that to be multiple days. We can also switch to the Jvm metrics, and the Jvm metrics actually support some custom views. For example, if we're interested in seeing the heap, we can go ahead, select a custom view, and now we're seeing just those Java reports that are specific to the heap. We can also switch to the application view. Just a quick reminder, the application view are provided to us through Spring Micrometer picks, a subset identified in the application. If we scroll down a little bit, we can see those queries associated with our recent deployment. Now, since they were done fairly quickly, you can see they're off on the end, but we can certainly narrow in on that focus to highlight those messages that were sent and received. Just to highlight again that we've only selected about a dozen of the available metrics that are in the Spring Boot Micrometer. It can be resource prohibitive in terms of cost of storage and network to record everything every time. The CSAP Live feature enables direct access to all of the micrometer metrics in the VM. You can see, since we recently deployed it, this VM has only been up around 30 minutes. We can filter these available statistics by JMS, and so we will highlight just those JMS metrics that we're looking at. We can select one of these instances, and let's look at the number received as well as the time distribution of the request. To do that, we'll go ahead back to the test surface and click on send messages again. Maybe wait a few seconds and click again. We can now see in real time these metrics being collected along with the time for each request. The advantage of the CSAP Live view is it enables you to have direct access to all of the counters in your system. So for example, when I remove this filter, you can see that we have over 163 meters available to us. When examining process data, it's always critical to keep in mind the context of the overall operating system. To do this, we have the OS performance view. This provides a critical context for all of the operations on the host. For example, if we drill in on the timeline for the MP stat information, you'll see that there's a little peak around 1320. If we switch over to the Performance tab and look at the events, you'll note that around 1320 happened to be when we were actually deploying the service. So it's important to note you can not only view the performance, but actually correlate with other activities on the host. The top++ view can be very helpful when diagnosing performance issues. One item we might want to do is to validate the actual Jvm parameters. We can launch the report, and here we see the exact parameters as well as the process tree for the service. We can also quickly look at the open sockets for the verify service. We can launch the command runner. You'll note that it has pre-populated the fields with the PID and the service name, and then we can click on run. Again, you can see the process scope information as well as the sockets that are in listening and establish mode. It's also worth noting when we're on the top++ view, it's actually filtering based on the CSAP services. So we are only viewing the process information and collecting that information for the CSAP services deployed. Unselecting it essentially gives us an enhanced PS and top view. So for example, if I want to see all the Java processes, I can add a filter, and this will show all of these services on the host using Java. And finally, the OS Explorer view can be very helpful in evaluating the context of the host as well. For example, if we were getting a port conflict, we might want to open up the socket listeners, type in the port we were interested in, and any matches would appear. Opening the port up will show us the process that's using it. In this case, it's Java. If we want to see the full context of the process ID, we can actually run the Pid Report, and now it'll give us all of those parameters. Here, we can actually see that it's the CSAP management agent. The Kubernetes and Docker screencast will go into more details on these two folders. One thing to note, on this host, I do actually have some containers running. There are a number of features integrated in the Explorer view. One of them is the ability to run CLIs ad hoc. So for example, if I want to run the ps-ef command, it'll come up with a prompt, and then I can get the output. Similarly, if I want to run the docker ps command, by default, the most recent command is at the top, and then any matches. So we can run a docker ps, and I'm just hitting my return key to cat tab through, and it brings those commands forward. It's slightly more in context than a full-blown command runner session, which allows you to edit the context directly. It also comes with timeouts, whereas the CLI runner has a default 30-second timeout. And of course, we can go down to the file system view, which will provide us with a summary of the mounted file systems. We can actually check out some of these. So for example, we have an NFS mount point. If you click on it, it will open up the file manager view with that file system selected. Clicking it again will get us back to that service default view that the view is currently associated with. We can also look at the OS cores as well as the memory and observe the latest collected data for each of them.